О, sorry. My fault.
I can shout.
У нас тут спикер без микрофона гуляет. This strange construction should be put on your head. Something like this.
Hello.
Yeah?
Okay.
It's his voice.
No.
And this should be put somehow on your belt or anything like this.
Will Pocket do?
Yeah.
Okay. Can you hear me? Такой вопрос организационный. На каком языке докладывать? Все скажут на русском, потому что никто, кто по-русски не понимает. Do we have any foreigners here? Would you prefer to have an English talk, please? Okay, so foreigners win. It will be in English. Okay, hi everyone. My name is Ignat. I work for Cloudflare. Who doesn't know about Cloudflare? You can ask your colleagues, like people sitting, what Cloudflare does, but in a nutshell, we're a network and security company. We speed up and secure websites and other properties on the web. So very interesting. We have a lot of interesting things going on, but I'm not going to talk about them. I'm going to talk about something else. I'm going to talk about Go as a scripting language in Linux. First, a bit about myself. I do performance and security in Cloudflare. I'm passionate about security and crypto. I also enjoy low-level programming, and my usual work is I like digging into internals of operating systems and see new ways how to abuse them or make them faster or make them slower or more secure or less secure. So that's what I do. Okay, this talk is about Go and Linux, which is a perfect talk for this conference. This conference name is Open Source and Linux, and Go is kind of a open source language. It was intentionally hard. It was made so it is very hard to do proprietary software with Go. Who here doesn't know about Go? Who doesn't like Go? And there is another talk over there. Yeah, so I like Go. I learned it when I joined the company. It's very easy to learn. So that brings us to the question, why do we want to use Go? Go is a programming language, is a generic programming language. So why do we want to use it as a scripting language? Well, there might be a couple of reasons. It's very easy to learn. So Go has a very small learning curve. And even if you don't have any engineering background, you can start prototyping and writing software very fast. Go has a huge ecosystem of ready code. And it's not only the ecosystem huge, you can easily get it, and you can easily install your third-party dependencies. You just use a simple go get command, and you don't have to write everything from scratch. There are tons of software which is tested and do what you want to do. And moreover, unlike other scripting languages or package managers for other programming languages, you don't require any administrative privileges. So like you as a user can install all the dependencies you need. Secondly, it's compiled and strongly typed. Who didn't have an issue when you write like a huge bash script to do some very complex task on your server or on your laptop, and you realize you have a typo in the middle of the script, so the bash script executes half of the commands and then errors out, and you end up with a system in an inconsistent state. Having a compiled language for scripting gives you some minor assurance that the compiler will catch these typos before even executing a single line of code. And Go is low level enough for system tasks. So it has more than easy integration with C. You can just paste C code directly into Go in commands, and it will work out of the box. So it's very easy to do like the bulk of your programming in Go, and if you need to dive deeper, you can use some C snippets, which will still be safe and convenient. So potential use cases. For example, Go build system for your project. If you have a complex project, you will likely use some of a complex build system. Go build will not be enough for you. But why would you use some complex build system written in Python for your Go project? You can write your own build system in Go and have a pure Go project. Another potential use case is quick Go prototyping. So you have this wonderful idea, you jump and to try some code in your editor, and you would like to quickly modify the code, execute, verify the result, and iterate fast. If you don't use it as a scripting language, you need to compile the file, execute, and like you do these many keystrokes, which slows you down. Some people say it's not a problem, you can compile the file if you need, but another potential use case is easier script templating. There are specific tasks. For example, if you want that you need your script to be in source form. For example, if you use that script as a config in your config management system, and you manage a lot of hardware, like in Cloudflare, for example, we have 6,000 servers across the world, and you probably need to template the script to make it work in different locations, in different environments. That's why you stick it in the source code. You add some templating language on top, which would all that would be impossible if you needed to compile your file. So basically, Go would probably be useful anywhere you use Python for your scripting. So they're very similar in this regard. So how do you do it? Go was not designed as a scripting language. So let's check what do you need for a proper script. Like what's the environment of the proper script? So first thing is an operating system, obviously. You probably won't write scripts for your bare metal IoT devices. You need some programming language to write the script. And the third thing, you need to have an interpreter which can interpret your programming language into machine code. Easy enough. So in this talk, as an operating system, we will review Linux, which is the only true operating system, and I don't know why there are other operating systems or clones. For programming language, obviously, we use Golang. That's because it's the title of the talk. And what is an interpreter for Go? So if you're familiar with Go, you know there is a command called go run, which basically, its functionality, you can feed it a source Go file, and it will execute it. So it feels like an interpreter. So let's check it out. So let's create a simple toy Go script, which is just an example hello world program for Go. Please notice the correct spelling of hello world. I see many examples out there which spell hello world incorrectly in their hello world program. So hello world starts with an uppercase H, has a comma, and always have an exclamation mark at the end. So if you're writing a hello world and you don't follow these conventions, your hello world is wrong and is misleading. Please remember that. So this is a proper hello world program. Let's try to execute it as a script with go run. So we use go run, feed it with the file, and we have our output, hello world. Seems all right, right? But that's not enough. So what do we want from a proper script, like more complex script? So the script should be able to parse command line arguments, because you usually send some parameters to the script for it to be more generic. The script should return proper exit code or exit status to the operating system, because it's also rare that you use the scripts on your own. You usually integrate them in a complex pipe on the shell, and that's how the exit status is one of the ways scripts interact with each other and communicate with each other and the environment. And finally, you don't want to be typing go run for your script. The same way you don't want to be typing Python and the Python file. You want to just execute the file and it should work. So what we want to achieve here is if we set the executable bit on our Go file, it should be executable as a script. So if we just execute the Go file, we should see our hello world. Okay, let's modify our toy Go script a little bit further so we can accommodate our requirements. So here, this is slightly modified hello world script, which accepts one parameter, and it will modify its output depending on the parameter. And also, if we send a special keyword called fail, the script will fail with a non-zero exit status code. And moreover, the exit status code will be 30. 30 is just like a random number, so just don't try to interpret it now. So how do we do that? How do we give a script? How do we execute a file as a script and we get proper output? The usual way it's done on the Unix operating systems is you put a shebang line at the top of the script. So does anyone don't know what a shebang line is? All right. So yeah, so I will briefly go through it anyway. So it's the first line in any script. It usually starts with a hash and an exclamation mark, and then followed by the path to the interpreter. So in Python, you will see some path to the Python binary. In Perl, you see the path to the Perl, etc., etc., etc. And the same thing we need for Go. And what it does is basically tells the operating system which interpreter to use to process your script. Please note that many documentation will mislead you, saying that it will tell the shell which interpreter to use. This is not technically true, and I'll get back to that later in the talk. OK, so let's modify our toy script and add a shebang line on top. So we will just add path to our Go binary and add a run and hope it will work. Let's try to execute it. So we failed, right? So if we execute this file now, we will see this error, and the script was not executed. So what happened here? The problem with Go is that hash, unlike many other scripting languages, is not a valid comment in Go. So we tried to execute the file. The operating system called our interpreter, but the interpreter could not interpret the file because it encountered a hashtag. Hash symbol, and it just failed, right? And even some other interpreters, for example, Node.js, they make an exception to process shebang lines, even though, for example, even though the hash is not a valid comment in JavaScript as well. But GoRun does not make this exception. And there have been some issues on GitHub. People ask for that specific exception, but there have been pushback from Go maintainers to add this specific exception to GoRun. OK, so when something doesn't work and people want it to work, they always come up with some workarounds. So if you go to Stack Overflow to research this problem, people say, OK, let's forget about shebang lines. We will try to exploit the properties of the shells itself. And what they mean is, if the script doesn't have a proper shebang line, most shells will try to execute the file as is, line by line, simply on the shell. And another thing which they exploit is that for file system paths, you can actually replace a single / to double /, and it will be still a valid file system path. But luckily, in Go, double / is a valid command. So let's modify our script again and try to execute this. So we will add this line, which I call shellism, because it exploits some usage of the shell. So we add a path with double / as the first line. And we also add these special magic characters, so our invocation will properly parse the command line arguments and return the error code, hopefully. OK, so let's try to execute it, but let's try to execute it this time with some command line parameter to verify it actually parses them properly. And we will fuse this. So we see that the script file did execute, and the command line parameter was parsed, but we see some garbage appended to the output, which is, so what happened here? The good thing is the script was executed, and the parameter parsing worked. But the bad thing is, after executing the first line of the script, the shell tried to execute the rest of the file after the go run command. And then it failed to process those. Therefore, we have this garbage attached at the end. Okay, if you go back to Stack Overflow, people are smart. They don't stop. They say, like, we'll fix it. We will add this exit at the end, so we will make sure that when you execute the first line, the shell immediately exit and we don't append the garbage. Okay, let's try that. Works, right? No garbage. Good. Let's try the failure mode now. Let's tell the script to fail. And when you execute it, you will see this. We will see the script properly failed, but for some reason, there was some output attached to the end which says exit status 30. We don't have this line in our script. And moreover, if you check the exit status, you will see it's 1, which should be 30, which is not what we want. Okay, so the script was executed, parameter parsing worked, the shell terminated properly in the good case, right? The bad, unfortunately, for some reason, go run masks the real non-zero exit code of the script and always returns 1. And moreover, it appends a line to the output with real exit status. People on Stack Overflow don't give up. They say, yeah, let's modify the line. If you go to the issue, you will see a very strange line, but I described it on the slide not to confuse people. They say, let's add some logic which will check the exit status, consume the exit status line, and return proper exit status. But at this point, you will see that it becomes too complicated. It's just not the right way, right? So if you see this shellism line and compare it with the typical Python line, it's like they're not comparable. It's just too complex. And an average reviewer or your script will not even grasp what it tries to do. Right? And moreover, if you still proceed, if you say, I will do that, there is another major drawback, which is not described in the Stack Overflow, by the way, which is a no-goer for me. So imagine you go with that complex shellism line, sorry. Let's execute our script again. It works fine from the shell. Now, let's try to execute our script not from the shell, but from any different process, for example, Python. And you will see nothing. You will see this. In the end, it will not execute, and you will see an error from the operating system, which is called exact format error, which means the operating system could not parse the executable format of the executable you tried to execute. Why this happens? Have to understand a little bit how Linux executes files. So imagine you have a user process, and the user process wants to execute another process. So in the nutshell, it uses an exec system call, and it sends the binary name which it wants to execute. The call is forwarded to Linux kernel, and Linux kernel has, because there are a number of different executable formats, scripts, binaries, etc., Linux kernel has different modules which can parse different formats. And Linux kernel just tries each module before it finds a suitable one. So if you, for example, try to execute a Python script, so there is a Linux kernel module called binformat script, which is responsible for executing scripts. So the script will actually parse the shebang line and invoke a Python interpreter for you. So the thing is what I mentioned earlier, the shebang line parsing happens in the kernel in itself, not in the shell. The shell has nothing to do with parsing shebang lines. Which means, that is the reason that our previous attempt didn't work. So with a conventional shebang line, the shebang line is parsed in the kernel, and regardless from which environment sends the exact call, it will be properly executed. In our case, our shellism hack is parsed by the shell. So it will work only in the context of the shell. So if you try to execute your script from non-shell environment, it will fail because Linux kernel does not know how to process this file. Okay, so shellism was throw away. Let's move back. We need shebang lines. We need to do something about that. And we know the go round is no good for us. It doesn't return the exit code status and cannot process shebang lines. Shellism is also not good. So what do? So when there are a lack of conventional, like official tools to do some task, engineers usually make custom tools. And that's what happened here. Instead of go run, people made a custom program called go run, which what it essentially does, it tries to compensate all the things all the lack of scripting support in the official go run. And so what it basically does, it consumes and processes the shebang line for you, and it returns proper exit status. So if we modify our toy script and just put a proper shebang line, but not invoking the standard go run, but our custom go run, let's try to execute it. So parameter parsing works fine. Let's try to fail the script. Fails, no extra output. Let's check the error code. Sorry, as expected. Nice. Let's try to call the script from Python, from another process. Works, good. And finally, so we finished with our script, and now we want to compile it to a real program. We want to commit our work. So we try to build the hello script file, and we fail. Why? Again, because the hash is not a valid comment in Go, and if you try to build that file, it will fail. So you can't have Go files which are scripts and proper programs at the same time, it seems. Damn. It seems we were so close. So the original blog post which inspired me for this talk finishes at this point. They say you don't have a perfect solution, but I didn't give up. So, okay, so maybe shebang lines is not for us. Instead of doing like a proper cross-operating system solution, I just focused on Linux, because Linux is a true operating system, right? So it seems the reason we're hitting this problem, we don't have a proper module in Linux kernel which can parse our Go scripts, right? All the modules which are there is not good for us. We need something else. But luckily, if you look closer, there is a module in Linux kernel which is named something else. It's basically called bin format misc, different formats. And essentially what it allows you to do, it allows you to add custom executable formats directly from user space. It allows the administrator to define new formats without compiling any code. So yeah, it allows registering custom interpreters for specific executable and scripts. And basically you can specify the executable either by header file, like by magic string at the start of the file, or by extension. And if you're interested more in that, surprisingly, it has very good official kernel documentation. You can just look how it works. I'll just give you a quick 101. So to use that functionality, you first need to the way you interact with the module is with a special virtual file system called bin format misc file system. You need to mount it first. You don't need to mount it if you use a recent systemd-based Linux distribution, because systemd will do it for you. Thanks, Leonard, wherever you are. Yes. And the second thing basically you have to do, you have to describe which files the system should interpret and how to interpret them. And this is just done by etching a properly format string into that special file which you see on the slide. So here is an example. First, we just check if the file system is mounted. On systemd-based distribution, you will see the output like this, that you already have this file system. And here is an example how would you register, tell the system how to properly execute Go script. So you see that the line is basically separated into sections, separated by colons. So the first section means just Golang is just a tag you attach to your description. The second big E means that we tell the system to identify the files by extension, not by header. And the next section just specifies which extension it is. It's Go, so all .go files should conform to this specification. And the final section, we specify the path to interpreter for a Linux kernel to use to actually execute these files. And the last section is some flags. I will not go into details now, but you can read about them in the documentation. They are needed there. So the way how it works is basically, if you configure it properly, for example, your user process does an exec system call with .go file. Because you registered this format, the Linux will forward that call to the bin format MISC kernel module. The kernel module will read the extension, check its database of registered format. If it finds the format, it will execute that file via interpreter. So in the end, you will have the new process will be executed as user something something go run and the path to your executable. So here is an example. Let's try a script. So this is the script, and you see this is a conventional Go program. There is no shebang line, nothing special about it. This is just plain Go program with which we started this talk. Yeah, so let's try to use that. Works, parameter passing works, failure works, no extra output, exit status is properly returned. Let's build this file. Because it doesn't have any extra weird lines, it's completely valid Go program. It will build successfully. And let's try to execute from another process. It will still work. Because now, the same as with shebang lines, the actual processing of the script happens inside the kernel. So now it doesn't matter which environment was used to execute the system call. It will still work. Yes. So that's what we did today. OK, some conclusions for this talk is that Go may be useful as a scripting language. If you consider Python useful as a scripting language, you should consider Go as a scripting language. They are very interchangeable. Unfortunately, standard shebang line is not compatible with Go mostly because the hash symbol is not a valid command in Go. According to Go maintainers, GoRun was not intended to be used as a proper Go interpreter, but we have our custom GoRun interpreter. And the bin format MISC is a neat feature in Linux which can solve all the above shortcomings and turn Go into a true scripting language. And finally, the thing I didn't mention previously, you may notice that bin format MISC is very powerful and customizable. So technically, you can throw away what I said before, replace Go with any language you like, and you can turn Rust into a scripting language, C++, Java, Haskell, Scala, whatever. In fact, you may research on modern Linux distributions in Ubuntu or Debian, you may explore this file system, and the standard package manager actually tries to install the bin format MISC descriptions for Java files. So technically, you can execute jar files directly without prepending them with Java invocation. This is finally, this is some home reading. So this is a link to original blog post, which inspired me to attack this program, which I mentioned stops at the end. You can't have a perfect solution. The second link is my blog post, which I take over and say you can still get a good solution in Linux. And finally, the last link is just a link to the bin format MISC documentation in Linux kernel. I encourage you to explore it. There are many cool features and things you can do with it. Thank you.
What about questions? Oh, I see. A moment. Please.
To be really useful scripting language, we need to specify some criteria. First of all, did you do some timings for the simplest script to run? Hello world.
You mean how long does it take to execute the script? Me personally, I didn't check it, but the people who responded to my blog post say they verified, and in average case, it was faster than Python. So basically, the compile time of the Go script plus the execution time was in average case faster than an equivalent Python script.
Thank you. The next question is, as a system administrator, I'm used to use some conventions about arguments. Do Go have something like getopt?
Something like, sorry?
Getopt.
Yes, it has a package for argument parsing.
It's not like getopt.
Well,
Completely different syntaxes.
more better, I guess.
That's the next problem. And the one more is packaging. What about packaging? Yes, Go has very wonderful packaging, built-in packaging system, but what about placing it in the system?
What about?
Each script wants each import, which has to be placed in correct place. As a user, I can place it in something like homedir, .go, but what about system?
So you mean system-level dependencies for scripts?
Yeah.
So if you need, so basically Go allows you to put your dependencies in the user directory or in the system level into the Go installation. So if you're an administrator, you can put your dependencies there.
Yes, but basic Python installation, with basic Python installation, you have almost all needed libraries to work with files, with...
Same with Go. Go standard library, I bet, covers 99%. So I never encountered any use case for my scripts or small programs which I needed a dependency. It actually provides more. I switched to Go because I didn't have proper dependencies out of the box from Python.
Okay, thank you.
What about other questions? I see. Sorry.
Можно я на русском, чтобы было проще? А скажите, скажите, как насчет конвейерной обработки команд? Вы заменяете Go, как скриптовый язык, как встраивать взаимодействие с стандартными, то есть со POSIX, как делать взаимодействие с его командами в Go?
Простите, не очень.
Ну, вы заменяете Go скриптовым языком, вы его заменяете башем, там, питоном.
Не, я просто предлагаю использовать Go как еще один скриптовый язык. Я не говорю выкиньте Python.
Не, я не предлагаю ни Python выкинуть, ни Bash. Но вот если мы будем использовать максимально Go, можно ли поддерживать в нем конвейерную обработку команд? Да.
Конечно.
Насколько удобно это делать?
Это все зависит от насколько вам удобно пользоваться Go. Но Go — это полноценный язык программирования. Там std-in, std-out очень легко работает. Это тоже как потоки, read, write.
То есть точно так же, как и в Python?
Похоже, да.
То есть заворачивать код точно так же, как в Python?
Да.
Все, спасибо.
I see one more hand.
Там есть.
Just a moment. Somewhere here.
Сейчас.
Hello. You mentioned it before that Go allows you to insert some C code into your program and execute it. Does it work when you use approach like executing Go as scripting language?
Yes, because Go run underneath actually compiles your script to a real program. So if you insert some C code in Go, it will work fine. Yeah, I actually had a use case last week when I needed to... The reason I switched to Go for this specific task is basically I needed to parse a PCI option ROM. And if you read the spec, it's all C structures and everything. So I tried to make it in Python, but also you have to decompress it and the compression algorithm in C. And I estimated it will take me a week to port the compression algorithm to Python. Instead, I switched to Go, most of my parsing to Go, and just take the decompression algorithm in C because it doesn't have any memory management dependencies, and it just works. I did my task in
One more question. I'm just curious. C allows you to insert some assembler code, yeah?
Yes, and Go as well.
Yeah, there was a question. Thank you a lot.
Yeah. Go, you can have ASM files and C files attached to the Go program, no problem. There was a guy there. Yeah?
Yeah, I'm just trying to be quick. If we are talking about the Go as one of the options for scripting language, so what do you see, what is the purpose of Go as a scripting language, not instead of Python or Bash, but what is the target of Go as a scripting language then?
So this is kind of new. I can't say we use it on a large scale now. It's just the reason I dive into this problem is the reason I just mentioned. So I'm used to work with many low-level things to parse some lower-level structures. I don't want to write C programs for that. And also, it's very cumbersome to write this parsing in Python because Python is more high-level. I just feel that the Go has this sweet spot between low-level language and C-like structures and high-level convenient language to do the parsing. But I don't want to be compiling my scripts every time. I just want to write things, check they work, and stick it somewhere where they're needed.
So if I understood you right, that means some way to manage your low-level activities with your underlying system, yeah?
Yes.
Instead of using...
Yeah.
That's answer my questions.
I see one more hand. Oh.
Does your Go run alternative cache binary in some kind? For example, in Python, when you first launch application, it creates so-called pig file or PO object.
Sorry?
It parses and saves result of parsing in file. So when you next time run this, it validates this preparsed.
I see. You mean the one with PyYC extension? Yeah. So I'm not sure how official Go run works in this case, and because it has all these drawbacks, it's not needed. The way how the custom Go run implemented, it also compiles your file, saves somewhere in the temp directory, and it uses the cache version if it identifies that the compiled file is already there. So next time you run your script,
cache stored on disk, yes?
Yes.
And another one question: how does it compare for such features that available on Perl and Ruby, like here documents? For example, in Ruby script or Perl, you can put some binary data. It could be absolutely anything binary data, not base 54 binary, and you can then use it in script. For example, in Ruby there is such framework like Sinatra, as far as I remember, that utilizes this feature to embed some files. For example, you can embed PNG image or something.
I see. I don't think. Well, I haven't looked at the frameworks for that, but Go as a general language doesn't have this. You can definitely stick a byte array definition in your source code. It will just work.
No, it's not byte array. It's just binary data. It's not part of a program. So for example, in Perl there is such term that calls end of program. And after this end of program, you can append anything, any binary data.
I don't think it's a very good idea.
For example, self-extraction archives using...
Why do you want to... I mean, it depends on the use case. Why do you want to embed binary data in your script?
For example, self-extraction archives.
Sorry?
Self-extraction archives. Some self-extraction archives using this.
Yeah, okay, I see. I'm not sure I can... Does Python have this feature? So,
hello. Thank you for your speech, but I have general question is why? Because honestly saying, yeah, you can still run as a script, but it basically neglects all the benefits of Go, where with the script you have ship your dependencies, ship interpreter, ship additional command line utility just to run the single script when you have just go compile, and ship the binary itself without any dependencies, without any restrictions that you are self-imposed on yourself.
I think what you said now applies to any scripting language.
Not
Why
really.
do you have any scripting language? Just write proper programs and they will just do what you want. And you don't have to deal with dependencies, right?
No,
Well,
I mean,
yes.
in general, yeah, like you're trying to like.
I guess I always compare Go to Python in that regard. One reason Python is so popular, it allows you to do very much out of the box on the standard installation, some people notice. Basically, this Go standard library is almost as good, if not even better in some regards. So, like, I do a lot of crypto. Go standard binary with crypto is way ahead of Python. And if you need to do some crypto, cipher tools, like, it's a way to go. So I guess it depends on how much you get. So, yeah, I agree that the dependency management for script is not a good place to be in. So, but if you can do bulk of your tasks, 99%, just with the standard library, it makes a good scripting language.
Okay, let us postpone other questions and ask them individually after the end of our session. Let us say thank you for speaker. And now is the next talk, I think. Assessing the security and privacy of your website by Tobias Müller.